Math is way more flexible and incomplete than they lead on.
This is one of the most baffling videos that I've seen, and definitely one of the most baffling videos she's done.
Even at the elementary level, lots of equations are incomplete. Lots of things are wrong.
And before you think that this is about Gödel's incompleteness theorem, it is not. It's about something else.
Calculating the surface area of just a thing, a ball, a tennis ball, whatever.
So the example she's using, the example she's referring to when she says that there are equations that are incomplete, is about the volume and the surface area in particular of an n-sphere. So if you take a sphere or a circle in 2 dimensions, a sphere in 3 dimensions, there are analogs in n dimensions, and she's specifically talking about the formula for the surface area of an n-sphere, of an n-dimensional sphere.
What they don't tell you is that equation starts to fall apart at a certain point.
Which was the topic of her thesis, according to her.
Your thesis was?
Surface area of spheres in higher dimensions.
And that's the most baffling part. I have no idea what she means that the equation breaks apart or that it falls apart, that it's incomplete. I really don't know what she's talking about. If you go to Wikipedia, to the page for the n-sphere, then you can find the formulas for the volume and for the surface of an n-sphere. That's the formula. It doesn't break apart in any dimensions. And you can find lots of resources where those formulas are derived. Just Google this question in Math Overflow, the explanation of the gamma function and the formula for the n-ball volume. And you can find several ways of deriving that formula and explain why the gamma function appears in the formula and so on and so forth. And it's just an easy derivation for a formula that works. It doesn't break. It doesn't fall apart. So
the surface area of this tennis ball starts to fall apart after the 7th dimension.
Okay, so because of that last comment, I think what she means is that if you plot the surface area of an n-1 sphere with respect to n, then it increases and then it drops. So there is a maximum value when n is 7. So for the 6-dimensional sphere, there is a maximum surface area, and then it drops. As n goes to infinity, it actually goes to 0. So I think that's what she means, is she's talking about this max value here, but that doesn't mean the equation for the surface breaks down or falls apart or anything like that. It's very well defined, and it's just interesting that there's a max, but that's it. There's nothing wrong with the math.